Good to see you all. This is my first time at this expo, and I think I haven't been to Florida in a long time, and I was pleased to see something I haven't seen in a long time, sunshine. Which, I'm based in Seattle, and we don't have a lot of that right now. As Ken was saying, I am part of Amazon Web Services. I am part of our IoT Global Business Development team. And I've been working mainly with our industrial customers for the last couple of years. In particular, I've been drilling into the oil and gas space, and I also work in connected and autonomous vehicles. So you'll see a few examples today that are more in the oil and gas side, and in that case, you'll know why. So today, what I want to talk about is just give you a few examples, some customer stories about what we're doing with our industrial customers and how many of our industrial customers are utilizing the IoT data to begin to digitally transform their enterprises. It's always good to begin with the true north, right? And we work with a company called Woodside Energy. Some of you might know them. They're the largest oil and gas producer in Australia. They're in Western Australia, based in Perth. They happen to be, I believe, one of the largest in the world, certainly the largest in Australia as a liquid natural gas producer. And they've recently spent about $10 billion building a new state-of-the-art plant. It's called the Pluto LNG plant. I think it was completed in the early 2010 timeframe. And they when they put the plant in, it sort of came with about 200,000 sensors built in the plant. It was a $10 billion plant. And what they began to discover is that there were certain processes. I mean, these plants are multi-acre plants. And it's one sort of gigantic fridge, really, right? Because I mean, the whole idea is to really super cool down the gas to make it liquid. So it's a gigantic fridge. And one part of the plant they were discovering had this problem called foaming. And it's like sort of beer foaming, but when liquid natural gas foams, it's a big problem. And so they had to stop that from happening because that actually shuts down the plant. And so they did a pilot in one of the areas in the plant using about 10,000 of the sensors. And I think took about 6 weeks to get the pilot going with us. And they were able to then predict the cause of the failure and to predict when the failure would happen, a few weeks out. And then after that, they extended that entire operation, that entire sort of predictive operation across the entire plant. So 200,000 sensors, I think running about 6,000 machine learning models, doing, I think they do mention in here about 3 million calculations a day. So it's a huge operation, and they are one of the most advanced companies that we work with in terms of how they're using IoT data to do their digital transformation. And actually, on the next slide, I'll introduce Russell Potapensky. He worked for Sean Gregory, who was mentioned on the other slide. Russell is the head of artificial intelligence at Woodside. And I thought it would be good to have him spend about a minute on this video clip. This is about a 40-minute presentation that he gave at our REMARS conference last June. But I think you sort of get an idea as to the extent to which they've begun to use IoT technology and also sort of 3D, digital twin, the virtual plant, and just the way they operate is pretty mind-boggling. So I hope I can get this video to work.
And pretty soon, you're starting to get that better than human awareness. So let's actually show you a little bit of a demo where we got up to about 6 weeks ago now. So you're looking at the Pluto LNG plant, the picture that you saw there. And what we're finding is our engineers and maintenance technicians, they actually love to actually walk around it in sort of the virtual sort of CAD view that you're seeing here. A couple of other things that you're seeing on the side, you're seeing what the tasks are of the day. Down underneath, you're seeing a time slider. And to the sort of left of the screen there, you're seeing the various kinds of data they can have. So this here, when we're looking at, is our water treatment plant. So we've moved away from proof of concepts with robotics or IoT systems, and we're actually fully now mobilized into a pilot program at our water treatment plant. So let's actually walk around it, should we see what we can see. So the first thing we can do is we can walk up to a piece of equipment, and it starts to present us with all of the data that's classically associated with that piece of equipment. So what's its flow rate, what's the temperature, pressures, that sort of thing. We can also incorporate all of the pictures that we have of that particular thing. You can see some of our IoT sensors, Cyclone strapped to that equipment right there.
Okay, so yeah, just a short clip to give you an idea as to what companies who are so truly using IoT and the sort of the 3D world of digital transformation, what they're doing with it. I mean, we are very impressed with this company and the way that they operate. If you want to see more about this, there's a YouTube video that goes in a lot more depth into this thing. So, I mean, what you picked up from Russell is exactly what they do. A lot of companies are doing, which is they are bringing the data in. They're bringing IoT data in as their new oil for digital transformation, right? And the companies that are at the most advanced end of this equation, the ones who recognize that they want to collect the data from every step in the entire product value chain and be able to feed that data into every other step, both for the purposes of improving all the steps and also to ensure sort of coordination across all the steps. So that's how they actually drive operational efficiency. So this is, in fact, the holy grail. I mean, I can't say that a lot of our customers have got this entire flywheel working, but that's the idea that most companies are actually working towards. And so why are they doing this, right? Because at the end of the day, what the promise of digital transformation is to drive profitability. You can either, it can help you improve revenues, and it can help you reduce your operating costs. Now, most companies, are focusing on the operating cost side right now, which makes a lot of sense. It's a little bit easier because it's a very, very sort of tangible problem. But we are seeing a lot of companies now who are actually using sort of getting into the revenue side of the equation too. And a good example of that is the whole idea of product as a service, where your companies are actually shifting their business models. They're shifting the way they actually interact with their customers. They don't sell you a product, they give you a service. Rolls-Royce, for example, a lot of their massive jet engines, they don't actually sell them, they give you hours of runtime. Or Michelin with their tires, they give you so tires and runtime, where they maintain the ownership and they switch the entire business model and the customer relationship. So IoT enables lots of things, but today we'll focus more on the operating cost side, right? So there are lots of issues that are faced by companies like yourselves on the operating cost side. I'll talk briefly about a couple of things. One is sort of optimizing your production, being able to do sort of production monitoring, and to improve the health, safety, wellness of your workforce, right? Two big important areas. I'm not here to sort of tell you the problems that you guys already understand. Equipment fails, leads to unplanned downtime. You get suboptimal production. Things cost a lot of money, right? And why does it happen? Because if you want to digitize your assets, you may have poor connectivity. You've got 400 different industrial protocols that all have to now talk the same language to go to the cloud. There obviously, the moment you start connecting devices, there's issues of sort of cybersecurity come in, and oftentimes you're operating in pretty harsh conditions. So what do companies ultimately want, right? I mean, why do you want to do digital transformation? I mean, you want to do it because you want to get enterprise-wide visibility. You want to be able to see all your assets, no matter where they are around the world, in one sort of complete view. I mean, this is my entire company. Now I want to see my division and how it's operating. Oh, now I want to see a particular plant. Oh, now I want to see a particular, actual machine or a process, right? Being able to see that complete back and forth. I mean, that's why digital transformation becomes extremely important. You want to be able to predict, to optimize, to forecast what's going on, to be able to drive the efficiency. You've got your workers walking around these plants. the example that Russell gave, that sort of virtual plant, their maintenance workers don't walk around the plant. They sit in their office, and they basically walk around the plant on their computer. They're able to see all the readings, all the gauges. Nobody walks the plants because it's kind of unsafe out there to be walking outside. So, and overall, you want to do all this at the lowest possible cost. I mean, that is the promise of digital transformation. Now, you might ask me, well, we do a lot of this stuff today. We have, historians, we have SCADA systems, we do store stuff, we do analytics. So why is there a need to have an IoT platform involved here? I mean, there are lots of reasons. Obviously, being able to see things on a global scale, be able to work on a global IoT platform like our platform and a lot of other platforms out there, being able to sort of democratize the access to the data so that not just a few employees or a few people, but people all over the world are looking at the same databases, being able to get the continuous sort of cost reduction, right? I mean, what we do as a company, because we have a large global platform, we are able to pass on the economies of scale to our customers, to you. And then, of course, when it comes to security, I mean, we take security as job one. So the end-to-end security processes that are built into the platform, that we can bring to your benefit. So those are other reasons why we believe that there is a value to moving on to a global platform like this. So let me grab a little water here. So the problem of optimizing your production starts from liberating locked data, right? So data is often locked up. Companies have been recording data for 30, 40 years, and a lot of them tell us, oh yeah, we got lots of data. We just never looked at it, right? It's locked up in their SCADA systems and their historians, and they were paying lots and lots of money to the historian companies, but they haven't really used that data for digital transformation. So the first thing we say is, begin to bring that data up into a format where you can look at it, not just by itself, but perhaps, commingle with data from other, local operations. So you start getting a broader picture. Only, companies are very keen to go sort of jump into the AI ML pool and say, hey, we want to do, sort of get the insight. We say, hold on. First, you got to, get the data, look at the data. You begin to understand what you actually have. Then define the business problems that you want to solve. And then define which of the data elements you actually need for the business problem. Because just bringing data up to the cloud, lots and lots of data doesn't solve the actual problem. You want to bring the data that you believe you need to solve a certain problem. Once you've done those two steps, look at your data, understand it, decide what you want to bring, then there's the potential to move from the descriptive to the predictive to the preventative analytics sort of process. So that's our recommendation when it comes to sort of getting into the production optimization world with digital transformation and IoT data. So just to give you a top level view, I mean this is our sort of the architectural view at the highest possible level from AWS. Our approach is we would have a kind of data lake that's your data lake, your company's data lake. You bring in the data from your on-premises, your on-premises SCADA systems and your historians. You bring in data from potentially other, sort of real-time sensors on the PLCs on the machines. Once you bring the data up, again, I was saying you bring the data up to solve the given problem. Once you've got the data into the lake, then you apply visualization tools to look at the data. You do some, simple analytics with SQL queries and things, and then eventually, as you get more sort of comfortable with the process, then you turn on the bigger analytical engines, the machine learning engines, to begin to, get a lot more insights, and then to take actions, you deploy those machine learning models back down to the edge to be able to take local action without having to have data go back every time to the cloud to take the action that were there. So that's the broad loop that we recommend. And once you have got the data up there and you go into the process, I mean, there's a whole broad range of typical sort of production-oriented problems that can be solved. So walk you through the high-level architecture as to how we do it, right? We talk about the collect the data and then take local actions. You transfer it up to the cloud, you store it, and then you look at it, visualize it, analyze it. And so the way, we've got intelligent gateways, we've got intelligent sensors, we enable local intelligence, being able to filter the data, do machine learning and control at the edge. We offer, security at the edge, and we have a wide range of qualified devices that, enable these things to happen. And, there are a couple of Amazon services. I won't go into those right now. We've got Amazon FreeRTOS, which is a microcontroller operating system that operates on sensors. And we have IoT Greengrass, which is an edge computing runtime, which enables machine learning and other applications to run at the edge. And then we work with a lot of our partners. We have the silicon partners, who are deploying, these services onto their silicon. And then we've got partners like Moxa, Adlink, lots of, sort of endpoints, the gateway companies that are running our services at the edge. So that takes care of the whole collection of data, and then once the machine learning models come back down to the edge to be able to take local action. And then you go to the cloud. And to be able to get data up to the cloud, we have connectors from SCADA systems and historians up to our cloud. We have protocol converters. We work with lots of companies like Kepware and Matricon Ignition to be able to convert their 400-odd industrial protocols into OPC UA and MQTT, which are the protocols that we use on the cloud side. We have time series databases to be able to manage the hot path. And then we have long-term, low-cost storage, what we call our glacier storage, to be able to reduce the cost of long-term storage. And yeah, so a couple of services. We have IoT Sitewise that does the actual data extraction from the edge. We have Amazon S3, which is our big storage buckets up in the cloud. And then we work with a lot of partners. I mentioned a few of them. The historian companies, we have connectors with them, and the protocol converter companies who are a part of our architectural path. And then you get to the visualization side. And here, this is where the action comes in, right? You want to be able to see things, the operational dashboard. You want to get alerts, reports. You want to do simple analytics like SQL. And then the most important one, eventually when you get ready for that, you can run machine learning models, up in the cloud, build them, train them, and then push them down to the edge and take local action. So that's the entire loop. And we have all our services like IoT Sitewise Monitor, is the visual end of Sitewise, which lets you, it's like an operational dashboard. We have SageMaker, which is our service, is not showing up, the icon not showing up, which is our machine learning, our main machine learning engine, and Amazon Athena is our sort of SQL engine as well. And then we work with partners like Seek and Uptake, who you've heard of, who build SaaS applications on top of our services. So this is the sort of the general way in which we can architect what we call our field to cloud back to the field solutions for production optimization. And, a couple of sort of case studies here. We have, SKF is one of our big customers on the manufacturing side. They have a system lubricator inside their ball bearings. They sensorize the ball bearings. They have a lubrication engine with a machine learning model that's picking up all the vibration around the ball bearings and sort of continues to give lubrication out there. We work with a company called Valmet, which is a Finnish company. They make these gigantic paper machines about 200 feet in length, but they are completely sort of sensorized, and they're using it to predict the quality of the paper. So they're looking at the sensors in the beginning part of the machine. They're able to predict what's coming out 200 feet down, and they're able to make adjustments now based on the predictions as to what they should do. So the paper that comes out actually comes out in decent quality. So with that, let me sort of cut over to the other point, which is the whole thing around using. What can we do for your workers on the health and safety side, right? So one of the things that we are using a lot of is using the camera and computer vision systems as a sort of powerful IoT sensor. And that is sort of enabling us to do things like being able to look at sort of fires and leaks that might be happening in remote locations that might actually harm the workers. It enables us to go to the north slope of Alaska and be able to, do sort of, meter readings, sort of valve readings, without having to send somebody out there to physically look at the valves and gauges out, 30, 40 degrees below 0 Fahrenheit in those kind of conditions. And then if you're using machine vision systems and sort of cameras, you can also use it for quality control. Obviously, they've been used before, but there's been so many advances on the vision and the camera side that now it's actually possible to do sort of high-speed analytics with machine learning, to be able to do things like quality control as well. But we'll focus more on the safety side today. The idea behind using sort of cameras and machine vision systems is to really supplement and potentially extend the power of the human eye. Because, cameras can see things when they're no human beings, or you can't even see things as well as the cameras can at the microscopic level sometimes. And so what you see now is a sort of trend going on in the industry where there've been sort of traditional vision gateways that have been out there for a while, right? The use of Intel x86-based systems. But now the next generation of vision gateways are using GPUs, for example, from NVIDIA Jetson TX2, GPU-based chipsets that are making the vision gateways much more powerful and able to do machine learning inference, actually have machine learning models running on the gateways and do machine learning inference at the edge. Next, to get even smaller, now you've got smart cameras where you can actually, build the cameras with these kind of chipsets and be able to build small cameras that do actually machine learning inference directly on the camera itself. You don't even need the vision gateway. And now people are even going even further, where there are companies like Umbrella, which is a Taiwanese company. They have a CV22 line. You've got TI with the Citara line. You've got NXP with the IMX8 line. These are actual chipsets that are so powerful now that is so much. They've got hardware accelerators and GPUs that you're able to now get extremely powerful machine learning inference directly into small devices. And they're now sort of ARM-based processors, so the costs have also come down. So the entire world of machine learning, using sort of vision-based machine learning is getting, more power and lower cost. That's sort of the trend line here. And we're using it now for lots of use cases, particularly in the case of worker health and safety. And there are sort of two types of scenarios. I'm calling it I call it the dumb camera smart gateway, which is the brownfield situation where you got lots of cameras that are already out there. So you don't want to replace your cameras. You just use your cameras, but you put a smart gateway that can do machine learning inference on the gateway. Or you have a smart camera. It's sort of greenfield where you don't have any sensors right now, or you sort of put the camera in for the first time. It's a smart camera system by itself. And out here what you do is you sort of take the video feeds, you push them up to the cloud, you use the Amazon SageMaker service to build a machine learning model, and then you push the model down to run on the gateway in the brownfield case, and in the greenfield case, you do the same thing, but you run the machine learning model directly onto the camera itself. And here are a couple of examples of that. I was up in the North Slope of Alaska last year, 30, 40 below zero, extremely harsh conditions. And they have to send a human being twice a day to 1,200 oil wells to be able to manually read valves and gauges. So this is an example of a brownfield situation where they were extremely keen. We went through the entire plant, and they said the number one priority for them in terms of transforming their operation was to fix this problem, because they were getting a lot of workers who were being affected by the conditions out there because of the regulatory requirements, being in the tundra up in Alaska. They had to send people out twice a day. 24 by 365, right? So really hard conditions. And so we have a pilot running out there, and once the pilot works out, they're going to now take it to the regulators and say, hey guys, this is a much better way to go. We work with sort of Marathon Oil. This is a kind of brownfield situation. This is another sort of brownfield situation. They had cameras out there. They had Bosch cameras, and they wanted to do sort of the health and safety of their workers. So they used cameras to ensure when a drill bit was being replaced. I'll pop a video up here in just a second. They were able to use that to do sort of safety of their workers. Now, if they were doing a greenfield, they wouldn't have had to use that gateway with a regular camera. They could have gone to like a 80-link camera like that with NVIDIA GPU and just do a greenfield project. So let's see just 30 seconds on this video here. So the video is basically showing that we are recognizing sort of clamps. We're recognizing clamps, lower clamp, upper clamp. The moment those clamps are recognized by our machine learning models, it gives an indication to the machine to unscrew the drill bit. Drill bits get unscrewed. Then people walk into the space. You'll see in just a moment here. And as people walk into the space, it sort of recognizes that there are people in the space now and gives a warning. Hey, there are people in the space. Be careful. So that's how we're using sort of basic sort of Bosch cameras with smart gateways running machine learning inference to be able to help with the health and safety side. And with that, I just wanted to leave you with a final thought that we are. I mean, I often refer to AWS as that we're kind of the plumbers of the industry. We do all the plumbing. We do what we call the undifferentiated heavy lifting. Building all the infrastructure. To actually build solutions all the way to the SaaS end that actually solves our customers' problems, we always work with our partners. So we have a large scale of partners who know how to use our services, and they understand the exact use cases. They get the hardware, they'll assemble the cameras, they'll put the whole thing together for you, and there are lots of things that we can offer you, working with AWS and our partners. So with that, thank you very much.